Hey, what's up? How's it going? It's Papa Bale. Thanks for chiming in. Like, subscribe, hit that notification bell. We're going to do 5.5 volts in on this. Now, I'll explain it as we go. Now, the drive coil is an 18 gauge. Trigger is a 32 gauge. Then I got a 20 gauge strand in there that I got plugged into the output. So it's not that good for the circuit, but it's awesome. So as long as it can handle the strain, it'll be all right. You check the distance there. I think that'll be good. You can always back it out a little bit. $340 right now. I think it would be increasing in speed a lot faster without that strand hooked to the output, but the amps would be way up too. This will gradually get to speed and cost a lot less energy to run. So I would say it's a little bit low on the power side though. 450. And then I want to hook this one up. This is a mean little devil. It won't go this fast, but it'll get going. $550. So I've got an 18 gauge as a drive. I've got a 32 gauge as a trigger. So that's all the connections on this side. That's 4 connections. I got a 20 gauge strand hooked to the output. So it's in there, it's hooked to the output. Yes! Look at that. Eureka. Oh, I changed it. No. Where's the up? There it is. Alright, one more test and I'm going to shut it down. 728. This will continue to increase in speed. And this will run, and this is actually lighting up the lamp on the SG right now. I don't know how. Maybe it's not. Maybe it's just the light from the window. And yeah, and the ash that's already on it. But anyway, this is what I'm. So it's a Trifilar coil. You got the 18 and 32 working as the Bifilar, and then you got the 20 gauge that I've now put back into the output. So when this thing spins just on its own when it's off, see, this is all momentum from the buildup from this what was just happening. Just having it be on. What I need to do is I need to have some sort of like a fourth strand, and that's what this one has. This one has 4 strands, and then that 4th strand would actually go into the power input. Thank you so much. Really appreciate you guys. And this is off right now. I think that's cool that it's still going. How fast is it going right now? Still going 470 RPMs. That's pretty cool. Now another way that I thought about hooking it up was taking the 20 strand, huh, that's a little strange. Maybe I had it like this. I don't know. We're going to try this one more time. It appears that they were reversed. That's more like it. See, those amps are not going up. That's more like it. Voila. And that's only like 3 watts. But what I want to do is I'm going to hook up that 20 gauge strand to the coil output along with the 18 gauge, just hook them up to the same outputs and see what happens. Yeah, that's 300. See, this is way different. This is, in my opinion, weaker than the way it was before. But I still think I'm putting in the same amount of wattage. I'm just getting less out. And that's having it parallel with the drive coil through the output. It's just parallel. This is positive, positive. I had it negative positive. And what I mean by that is the beginning of the coils, like where the strand, where it starts, it was both where it started. And I believe they're both wrapped the same direction, so. Just kidding, just being a little, see, because of course they're going to be wrapped the same direction. So this is parallel right here. Now I think that if I switched it right now, I would blow everything up because it was pulling like 300 milliamps, 400 milliamps down at 5 volts the other way. Alright, I'd say this is the vehicle's max speed. Doesn't sound like it's getting any faster. 310. Alright, let's switch it up. Okay, so that was a 20 gauge strand connected to the output in parallel to the drive coil. So now I'm basically going to turn the 20 gauge into another drive coil. All right, let's turn down. All right, here we go. All right, this is 3 volts in. Feel like I'm already going faster. Let's check it out. Oh, 206. All right, let's put it up to 5. Hold on. I gotta put something on the output here. It's not healthy. Not healthy to not have an output. So I'm gonna hook up the light bulb for the output. I don't know if the light bulb's in the shot. Yeah, it's in the back. In the lampshade. And this will also make it run a lot smoother. So 5.5, about 300 milliamps. Now I think hooking the 20 gauge into the output in series to the drive coil runs really smoothly, and it's almost as fast as this. But I think it's because it's not really interfering or contributing with it being backwards. In my opinion, it's not backwards, it's just in series. It goes beginning, end, instead of beginning, begin, end, you know. You can't really hook them up the same way in a linear fashion either. One's on top of the other one. So it can't be like, it's not a forward thing. It's like an up and down thing. So we got up to like 724 with the circuit that I just described. We're at 510 now. It's not really the circuit. The circuit's staying the same each time. We're just changing the way we connect to it. Because this circuit is dope, man. This circuit is awesome. So many different ways you can hook it up. But there's one way you're meant to hook it up. It's kind of like this right now. And it's meant for a bifilar coil, not a trifilar. The trifilars are nice. 650. $1.5 watts. $700. Woo! I can hear something now. $750. Wow, the camera really doesn't give this thing justice. You know? See, this is where that fourth strand would come in really handy. When it's going this fast, that fourth strand is going to be generating a lot. Those are 40 millimeter round neodymium magnets embedded in the side of this thing. So that it's going to be generating a lot of electricity. Counter rotator. It's going to get going pretty fast. $24 volts. Freaking awesome. Whew, that hurt a little bit. See if we can get it going. I don't think it's going to start. Oh, it's going to sink because it's so light. And the cores to the coils are iron infused PLA, so it's gonna sink as you get some going the other way. But it works. I'm gonna put this battery right here. Where this breadboard is, I'm gonna put the battery right there, and that'll give me the weight equalization. And then I'll put the breadboard and all the lightweight stuff right on top of it, of the battery. So it'll be like that, just reversed. Just flip it around. And that should equalize the weight on all sides pretty much. It'll be a 36, then hey, too legit to quit. I love that song. Oh no. Greetings. No, don't get me wrong, dude. I read tarot cards too. I do all that stuff, man. But you know, I'm not selling anything here. There I would have to beg to differ. That was different. I worked at a flea market. Actually, I had a store called the Rock Shop. It was more interesting than just tarot cards, though. I sold semi-precious gemstones. If you catch my drift. One of my prize gems with this labradorite, it's just chunk like this, man. It was beautiful. So I got the bearing that I need, and maybe the balance that I need as well. Fidget spinner. All right, fidget spinner versus my pulse motor on its off phase. Which one's going to spin longer? Yeah, the wheel's already been spinning for like 10 minutes anyway. No, granted, I didn't whip it very hard with the fidget spinner, so it doesn't really count as even an experiment, but it was fun to like. A flux capacitor? I don't know about that. I guess it's all based on how you hook it up, right? It's going to look the same to everybody, but how you hook up to it is going to determine what comes out of it, where it comes out, why it comes out. It's really all about connections and how they're made, right? Even the power that's coming out of the power supply is chemically or atomically on that level. That's okay. I mean, knowing that doesn't make you any dumber or smarter. It just is. Saying something that is okay. It's okay. It's not a waste of breath. Wow, man, that thing is still spinning. That's pretty freaking awesome. Um, it's a DC brushless motor that now the rotor has been running. Let me look on the clock here. I believe like 15 minutes. Well, I've been talking and running this and other things, playing with the fidget spinner without any source input. Yeah, the Bifilar is more like a Tesla coil. You got a primary and a secondary, as far as I know, and a driver for your Tesla coil. And yes, there's a primary, there's a secondary, and then there's a trigger for this driver. Like a more focused. I agree. Because you got your primary, your secondary, and you got your driver, so in that way they're the same. But this is much more focused. The intensity is focused right here. In a Tesla coil, it's more radiant, and um, yeah, I'd say it's all about the radiance from the area, and you can transfer that radiance. I've been watching this um, show on Old Man Builds, and he was showing like what can hold the Tesla coil field. The one wire connection, you touch that wire to a substance, and then it'll have the effect of the Tesla coil. Awesome stuff, man. Totally cool. And I understand how that works. It's like a transference of resonance, and I believe it's equal proportionately to the power of the coil. I'm not exactly sure, but it's awesome. Really cool. So I do want to hook this one up. Unfortunately, 50 turns is too short to trigger. I've tried everything. I've tried this rotor. I've tried another rotor. I've tried different magnet strengths, and 50 turns is not enough. So I need to take the last two strands, put them in series, and have the first strand go to the drive, and the second strand go to the output. Or the second strand can go to the. But when I put the second strand on the drive, the amps go way up. And this is just a little tiny 32 gauge coil, which they shouldn't go that high. And when I put it on the output, they go way down, so that's what I'm going to do. And then I'm going to make another coil like this, except it's going to be 100 turns. And then we're going to see something, because then I can take that extra strand that I got to put into the drive, and I can put it directly into the power input, and then everything will be cool. It's got very little like suction ability, if you get what I'm saying. It doesn't slow the rotor down because there's such little amount of copper in there. Yes, very, very good. It is an electromagnetic coil, bouncing off some permanent magnets. Hey, hey. How's it going? $600. $690. This is 5 volts in, 5.5 volts in, 300 milliamps. You can kind of see it there. Got a hell of an acceleration phase. It's been going on for quite a while. 727. $775. I would let it go, but there is one magnet in there that is not glued in, and it's just taped in there with the rest of them. So it's not that it will fly off, it's just the balance. It could definitely catastrophically fail here if I let it go too fast. Alright, now this thing over here is really cool. Just watch this. I'm gonna spin the bottom this way. I'm gonna spin the top this way. Wow, it's going pretty fast. As you can see, that pole is not in there very good. But it is screwed in. Hmm. Now, see, I want to try this. I have these. These type of transistors right here. I want to hook up 2 of these to this coil right here. So it does look like in series is way better than in parallel. But the light is on. And what I mean by that is the light on the circuit here is on pretty steady. So that's about 1 watt in. Nine-volt battery. Probably run for about 5 minutes on a 9-volt battery. I mean, at 400 milliamps, it's not going to last. 650. $700. That was 762, and it was off for a little bit. So let's say about 850, maybe eight, a little less. I got PTSD, man, so when I feel like it's gonna not be good, I turn it down. mm. Alright, so in order to hook up the other coil, and I mean, I can't wait to get it so that it really works. I mean, if I could separate all four strands and have it trigger, I'd be like so happy right now. No, I don't think it'll get going anything like this, really. I gotta just get a moment here. You see how bulky this coil is and how much copper there is there, and it runs it very well. That coil literally weighs like 1.5 pounds. And this one weighs like 1/10 of a, more less than that, like 1/50th of an ounce. It's really light. go. Then we link in series AC strands 3 and 4 together. Strand number 2 is what's left, and we hook up strand number 2 to the parallel with the output. And well, bam, let's see, let me look. I wasn't timing it, but yeah, we're still under an hour, so that's pretty cool, pretty fast. This is a 50 turn, 32 gauge, 4-filar coil. Oh, nothing's, that's not right. All right. Hmm. I have a feeling that it's these wires that are all bunched up down here. I don't like this. Yeah, man, I don't know. I'm just going to hook the other one back up. This one's not working right now. Maybe it's a little bit too much for right now. There we go. Maybe we'll give it another shot in a minute. Wonder about what I could do with my homemade reed switch. So there's the transistor, which you just saw. It's nice and smooth. It'll go fast. Here. We're going to get rid of the SG just for a second. In just a second. Awesome.
Another one, not today though, but I'll buy you one. And you can get rid of two. And then we can throw away all the old ones. Do I go over this?
All right. We can bust out the pancake coil too later. Goodness. So power goes in right there. And power goes out the other side when there's contact. So in that way it's a commutator switch. It's both really. This is heavy duty like a commutator, but at the same time it's got some speed like a switch. Now it is low frequency, I would say. We are going to glue that down. Now it gets plugged into the other side of the switch and then grounded to its other side. Alright, if I get this in the right spot, it should self-start. But you see how violently this coil is shaking. It's not shaking from the table rattling. Maybe you don't see it. I can't depend on my camera to catch that. Because it's shaking, it's just doing it really fast right now. So this is the 18 gauge on like pure energy. Hey, where you guys off to?
I'm going back to the store with Caleb to buy him some underwear and some more underwear and socks.
Awesome.
Come on. Paige is not going.
Okay.
Alright, ready? You like those hoodies?
Yeah?
There you go.
Awesome. Alright, put it. Not on the mat yet, that's good. Alright, so now I'm going to hook up the 20 gauge strand the same way I hooked up the 18 gauge strand. Insert versatility. There's the 20. Now I need to ground it. I wonder what happens if I do this. Yeah, we're not going to do it with this one. We'll do it with the 32 gauge. We'll ground this one. We're pulling almost 2 amps though. We got 3 volts. So that's like 6 watts at 3 volts. No sir, we're getting there though, we're gonna get there. It's gonna take forever, but we're gonna get there. We're close. But no, this is a magnetic switch. It wouldn't happen with a magnetic switch, I don't think. Heck yeah, man, we're gonna move this out like all the way to here, see what happens. Got the switch in there nice and close, so it's gonna hit, but there's a field gonna push the wheel at that, spacing. Alright, now we're gonna hook up the 32, except we're gonna hook it up a little differently. We're gonna have the starting side of the 32, which I believe makes it a south-facing coil at this juncture. And we're gonna hook it up to this right here. And we're gonna hook the other end up. I think this is the only place we're gonna put a diode. And we're gonna force it to go back into the power side of the switch. We'll give it a little boost. It always works better with a little bit of speed. It's 3 volts in, ladies and gentlemen, about an amp draw. So we should get some arcing here when after I turn off the power because of how I hooked up that 32 gauge strand. Is it gonna go forever? I don't know, it's gonna stop. Most definitely gonna stop, but I don't think the goal should be to go forever anymore. What's the point? That's awesome, man. That's 3 volts. That is just, it's great. That is 2 AA batteries right there. Yep, still arcing. Oh, we got something here. See, the power is off. It's not going to go forever, like I said, but this will go on its own capacitance. There's no capacitor here. So it's going on its own capacitance. We are getting arcing. This is great. And it's all because of how I hooked up that 32 gauge. Now, I believe it will settle into a range where it will continue to move and lose speed at a slower rate. But as far as the rules go, no. Gotta repeat myself. This is not gonna go forever. It's gonna go for, we're gonna find out, actually. Because the combination of the permeability of the copper in this coil and the magneticness of the switch, little screw in there that makes it work, it'll stop. Doesn't matter what's going through it. If it's not power, it'll stop. What I mean by power is both volts and amps. You need your wattage, or you need to have it be void of any kind of obstacle. But so far, without using the cap, all I've been able to get to force through is mainly voltage. I get very little amps. When I get enough voltage to run it, I mean, I get very little amps at that point. I need a cap to run it on amps, I think. Or to do the coil parallel to the switch instead of series from like the switch to the coil to the ground. I'd have to go make a parallel connection. That might be interesting, actually. Don't know if it'd work right. Work at all. So that's an interesting thing to note right there. The amps went way up, and it slowed down because it wasn't going, didn't have enough momentum to keep going. I don't know what that was all about, but the amps went way up, and I had to spin it. I think it's because of the 32 gauge that I hooked up. Honestly. All right. Oh, that is cool. So what I'm going to do now is I'm going to take this ground, which is the 20 gauge, I'm hoping. Yep. And I'm going to hook it right here. Oh, I need the diode. Dang, that was close. That was really close. I don't know, man. I don't think you're supposed to connect these things so the power can fly back. If you're going to do that, you should be able to catch it first, I think. I mean, could really mess up your stuff. Alright, so now we got the 20 gauge. We got two strands going back into the circuit. So it sounds like it's slowing down a lot faster. So I don't know. I'm thinking the 20 gauge should also be a drive instead of a source. Or maybe we'll make the 32 be a drive and the 20 be the source. Let's give that a shot. See, they like the two drives. They like the dual drive. So we are getting some arcing. Oh man, we could hook this coil up and do it like this. I bet you this piece of plastic here would jump. You get another glue stick. Okay. I think this is going to be interesting. It's not going to go super duper fast. Not like this. .150 gauge on 150 turn strand. There's something touching, so I gotta. Hmm.
Go to your drawer and find all your underwear in your drawer. And bring them out and pull them out. One.
Probably seems right. Let's hook up another one. I'm starting to think that the coil itself may have melted, but that sounds more and more crazy the more I say it. And because it's a new coil, it could be the position of the reed switch too. Probably easier to just move the coil. Yeah, I don't like it. I was doing some pretty cool stuff with it earlier today, but it wasn't with this. Anyway, I'm gonna make another one that's 100 turns of 4 strands of 32, and I think that'll rock. I wonder, is there anything else I want to check out real quick? Yeah, there is actually. I want to do this. All right. Hi.
You live? Alright.
Now stop eating.
So this is a 26 gauge trigger, so I'm gonna dual wrap it.
Please start realizing.
Alright. There it is.
Hi, kitty.
We're gonna use the SSG. We're gonna spin the ball. We're gonna spin the sphere. We're gonna use SSG. I guess we'll be done with this for now because I need the space.
No!
Stop it.
I'm asking him a question. I can't understand it. Do you have a duck? There it is. Sound better? Do you have a duck? Oh.
Yeah.
Yeah, I was asking.
Right.
I haven't done the race before. I've only done like the infinite one. No. Why do I?
Good Lord.
Oh, let me play.
So we got our coil hookup. This is a 16 gauge bifilar coil with a 26 gauge trigger. All right, we're almost done hooking this part up, and then the next part should be pretty easy. I'll move it over here and we'll get started. But I want to have the output hooked up too. So let's do that. All right. This will clip to the lights plug. That's what it's called. Alright, so we want to put this down and let's turn it on. There it goes. Pretty freaking cool, man. That's awesome. Just going really, really fast. I love doing that. I think Dad needs to go do some parenting. You got this? Okay. Yeah, we don't tolerate the physical stuff around here. Wow. I think this is my pre-pro. Yeah. All right. What do we got? I guess we'll hook this back up. Okay. Turn around. Now, I actually want to see something. Since this is a single file coil, my reed switch would be perfect for this coil to be a drive coil. Wow. It's got a soft iron core. Got to put a little glue on it. Man, maybe I'll take that core out. I don't know. That's a pretty big air gap. But you know what? I think we'll be all right. Hi, little tags. Hold on. Hold on, baby. Go on, little guy. So I need a little bit more glue and one more clip.
You better, where's your drink at? I wouldn't let it sit for very long.
More complex than you think, Caleb. You should see when you get to Mars how bad this thing really gets.
This is as simple as it gets.
I don't know. So was it red, yellow one? Or was it red? So it goes from yellow to blue to red and then back to yellow. Yellow to blue to red. Let me do this.
So it's not super spectacular. I do feel something happening though.
Yo. This is so hard. It doesn't, it doesn't look that hard, but it really is. Everyone playing is like. Caleb, you must think. I don't know what you did, but you did something. It's not water, Caleb. Give me this.
Right.
It's not working. I switched. This game really hates me. It's not working. It's not working. No! What is it? I can't pause the game, so like. Caleb, it works.
you go. So that means I can put it just right up next to it. What the hell? Back it up a little bit.
We go insane.
Hmm.
No.
Just looks messy, bro.
Listen, don't leave this on the floor.
Yeah, sorry.
This is supposed to
Just looks messy. It's an optic.
So don't go in this.
Got some transistors that are loose. Maybe a battery or two. Yeah.
Make sure when you put this on, the ribbons are behind that, like that. Make sure you just still stick it on your hand.
It just looks messy. Because I use glue. But yeah, I don't disagree that it needs to be cleaned up. But I've seen way worse. Or is that not the answer you were expecting?
No, not really. I'm leaving.
Okay. Yeah. There's just a lot going on here. Hmm. Yeah. Do you have kids? Just wondering. Because you know what's coming after this. If you don't. Hmm. Oh man, because luckily, just because I'll be the one to crack it. Just with my workbench here. So you know how people do 9-volt batteries? That's how I do 9-volt batteries. People should do it like this. There's an on-off switch on this. I'm just advocating for having a case that has an on-off switch, man. It's really useful. All right, now I want to try to use this as a drive coil, but it's a single file coil. I've been using my reed switch, but it's not working right now. It's got some corrosion on it from lots of arcing. So I gotta find something else to trigger it with. I could use this SSG circuit, I think, and just have an external trigger. Yeah, I got a couple 3D printers. Got this one over here in the corner, and I got that one over there under the TV. All right, so I think I'm going to use this coil as a trigger real quick. It's 32 gauge, it's 2 strands. I'm just going to link the strands together. And you know what? There might even be enough reach on this big ass coil to put it right in front of it. I wish I would have known I was going to do this. I don't know if this is going to work, but we're going to give it a shot. It won't work behind it, I know that, but maybe in front of it. And I don't know if we're going to leave that iron core in. We'll leave it flexible. But this little sucker fits right in the middle of that. Yeah, I want to get rid of this glue. Maybe not. So who wants dibs on whether or not that's going to run? I'm going to use this circuit right here, SSG. Now, you haven't been here long enough to be asking questions like that. You know there's no objective. There's no end game here, man. We're just building stuff. We're testing things out. Feel free to give a shout. As long as it's about something on the table or an idea that you might have in regards to something on the table. This is actually a counter rotator. I'm gonna burn that in a second. We're gonna set it up and get it going in a second. It's battery operated. And there's no commutator. It's got a trigger switch, or trigger coil. Oh my gosh. All right. That took longer than expected. Oh, that's the positive end. Believe it or not, I was using all that stuff. And that's okay. It's definitely okay. All right. So then now we're going to do this trigger that's chilling in the front of the drive coil. God. So much energy goes into this. After you hook it up, they're instantaneously, unless you tape them down, twisted. They're intertangled. Now, because it's not a bifilar coil, I don't know if it's going to work or not. God. Serious right now? All right, green. Hopefully these coils are true. There we go. And on. It's kind of hard to tell. Well, I know the amps are running like it's running, but it's slowing down. So I don't know if it's going to stay like that. Turn up the amps a little bit, voltage. I don't know if it's got that much reach. But the output's on. I was just seeing if I could use this coil, single file coil in an SG setup and it doesn't look like it's going to work. We're going to put that soft iron core. Yeah, that's like nothing. So I'm wondering, I gotta take that core out though. If I move it over one magnet, and move this one up as close as I can. That's a PL iron infused PLA. All right, I just need to get something to prop that coil up on. There it goes. It works. It worked. Oh yeah, it's pretty violent too. How hard this one is pounding. I can feel it like jolting. So it works as a drive coil, just it's not that great. But I mean, it worked more as a motionless than it is as a kinetic coil. Because I can feel that pulsing through there, like there's a strong magnetic field on this. All right, let's start up the counter rotator. All right, so each one of these coils is a wedge-shaped coil with an iron-infused PLA core. They're bifilar coils. They're 32 gauge and 20 gauge. This is the stator, and the stator, as you can see, is spinning. So that's part of being a counter rotator. Your stator has to be able to spin. I got diodes. This is all DC, and they all go that way. So the stator is going to be spun that way. I tried doing it both ways. It doesn't do it both ways. I think it has to do with the diodes that I have in there. But anyway, the rotor is going to spin the other way. And it's going to get pretty fast. It's going to get pretty violent. Because it's not on there very good. Heck yeah, man, that thing's starting to rip. So the only problem that I have is I've lost all my M.P.H screws. So there was only one screw lying around and I used it. But as you can see, one screw is not enough. Well, it's enough, but I mean, if you want it to be any kind of safe. So this third battery pack, I've been saying, I'm going to put it right here. And that'll balance the weight. Huh. I have an idea. Eureka, I think. Because I have one more of those obnoxiously large coils. That apparently is the right size. I'm going to put the output of the SG into here. I think it's coming out as pulsed. Oh, duh. It's not going to work because there is no output currently. Because the trigger coil is not, it's not a bifilar coil. So you don't get that output. So I was planning on putting this one right here and have the residual spin charge up this one, but I don't see it working without. I have an idea. Let's hook up our Trifilar again. We'll hook up our Trifilar coil to this coil. Yeah. So the objective is to have fun. And to the point, to the extent that when you remind yourself that you're just having fun and you don't get carried away. You don't get carried away. Gosh, it is so unbelievably tangled when you're dealing with this stuff. As if you're going to do it like this. You're going to go like real time, not off a schematic. And then there are things that you are going to want to use a schematic to do. Absolutely. I just don't think this is necessarily one of them. Like I said, one of those magnets is loose. That's why I got the tape on there. All right. Cool. So I think the Trifilar coil part, one of them can go on this one. and the output can go into the other one. I mean, the worst that could happen is that it doesn't work. Pete, Mike, what's up? Alright, so now I'm using all the outputs to try and run other coils. I'm hoping that it'll be all timed by the trigger coil. Yeah, that's not smart. Holy smoke. Alright, it was only 3 volts, but still, not smart. Alright. And this will go here. Now let's turn it up to 5.5. Six and a half will work. Well, it's not slowing it down, I don't think. That light on the SG circuit is lit like steadily, so this probably isn't the best way to run this circuit, but it's working. It is not failing me. 9-volt test. I'm drawing about half an amp. It's pretty. That's a lot, in my opinion. And our light is lit to. It's blowing up, man. It's bright. Oh, thanks, Pete. Heck yeah, I love that thing. I mean, I gotta clean it, I guess. Make it function properly again. It's like the copper on copper, and then it sticks sometimes, and like 15 amps go flowing through this thing. Amazing. There we go. $705 RPMs. $775. $790. Oh, we're still getting a light. The light is still flashing in the SSG circuit. Power is off and the light is still flashing. That's funny. Now, what I'm thinking about doing is running this coil just on the wheel and plugging it into the power. So when it's off like this, yeah, let's do that. And it's gonna have to have diodes in it. Huh. I'm all out of things to prop up on. I'm using, there we go. Excuse me a minute. All right. One more moment. How you doing? All right. Now, oh yeah, power supply. I wonder what's going to happen. If put an extreme, load on it, I don't know what's going to happen. I really don't. First attempt at doing this. All right, here we go. Now that's awesome. Here we go. Every little bit counts. All right, let's turn it off and see what we get. Oh, I hear that. That's that one magnet that I told you about. Now that 32 gauge coil should run this for a little bit. I mean, it is in parallel. I don't know if it should be or not, but that's what it is right now. All right, I got another idea. Negative. Gonna hook that 20 gauge parallel. Okay. With the output. Let's finish up here. We're going to take these big coils off. I've satisfied my curiosity. I am concluded that they are going to be a hindrance. They're going to make it run any smoother, any more efficient. At least the way I had them hooked up, they weren't going to do that. All right. So get this out. All right, let's try this now. So now the output is going into the Trifilar coil, into the third strand. That's all the way up. All right, I'm gonna try to put it in series. It's in parallel right now. I'm gonna put it in series. Let's see what happens. All right, so in series, the light is out of control. The light is on. This is, although you can run it this way, it's not advised that you run it this way. The SSG drive is what I'm talking about. All right, I'm gonna try. We're gonna run the 20. Let me make sure this is right. Negative. We're gonna run the 20 parallel with the 18 gauge. What's up? And we're gonna do negative. That's a positive.
I've never been this high. I think it might be a little longer. I want to be longer.
So that's the positive.
I'm spinning the fidget spinner.
It's going right here under the clip. Under the plug. And we got the 20 gauge going parallel with the 18 gauge on the drive output. So here we go. We got Insta Light. You want to get that? Fidget spinner? About 200? That's not right. Let me see that. $604. Now, could you get the fidget spinner off of the ground, please? Thank you. So neat. That's 9 volts. That's a 9-volt battery. Move. When you hear it rattling like that, man, don't just chill. I know. It's just the coil got too close, or that magnet popped out too far. Either one.
You're trying to spin it and it falls on my hand.
But anyway, now that coil on the other side, on the far side, is AC dumping. Well, no, it's got rectifiers on it, so it's DC dumping into the power.
We're almost at 3 hours.
Yeah. That's awesome.
5.25 to go.
You can hear it running. Hmm. So I'm pretty happy with this. The dual drive is probably the best way that I've had it hook up so far. The way it is right now, probably the best way. And not because I said it was the best way, but because I tried every other way that I can think of. And if there is another way out there that I haven't tried, it could be that way. But this is the best way that I've tried. And the objective is time after you turn it off that it's still on, basically. I can still hear it chirping away. So the objective is the amount of spin without source power do you get? And is there any way to improve that amount of spin without adding power? You can add a coil, but you can't add a battery or a cap or anything like that. You can't add that. You can't add a power supply. I'm talking, you can add a power supply. You can use that to spin it up. But once you turn it off, you can't put it back in anywhere in the circuit. You can start it and you can run it. But once you turn it off, you can't turn it back on. You get what I'm saying? All right, we'll see. We'll see. And I mean, there's probably lots of other cool things that you can do with all that stuff, but that's not what I'm trying to do here. And I mean, there's one thing that I do want to try, and that's the flyback battery swap deal, where the batteries swap energy. That's one thing that I do want to try, and I know where to get it. But I mean, the coil wise, that's a very specific build. I mean, it has to be specific coil wise if you need a specific amount of energy to make it work. But this is cool, man. I can still kind of hear it running. It's very faint, but you can tell. Because when you turn it on, it's that same noise, but it's louder. No, I'm not trying to store anything. There's no caps, no batteries, nothing. It's all flow matrix. It's all, as soon as it feeds itself, that's what it does. I'm not trying to store anything, no. And you can't use it. This is what it is, man. I will draw you a schematic of this if you'd like. There's a source input, which is going to be a power supply, a battery, or a cap. Well, once you remove that, and you do remove that from the circuit, You can't put it back in anywhere in the circuit to store energy, to do anything with. That's what we're doing right here. Now the other thing that I was talking about, yeah, you basically swap between two batteries.
2, 1. We have 3 hours.
Sweet. But this, you get it going really fast. That was really fast. That's probably the fastest it's gone all day. And then, there's lots of different things you can do at this point. But what I've done is I've attached that far coil on the far side to the power supply, the power input of the SSG, in parallel with 2 diodes. So the power is just going in. And I don't know how the power flows here. So if it goes in and then out, then I'd have to put it the other way, wouldn't I? One of the diodes would have to change. Maybe not, I don't know. All I know is that it dumps into that main drive. And then there's a 18 and a 20 gauge, which are hooked to the coil output of the SSG. So they're both running as drives. And then there's a 32 gauge strand in the Trifilar, which I'm using as a trigger. So that's active all the time. And then every time a magnet passes that coil on the far side, it sends a shot through the system. So it's just not very big. It's a small 32 gauge coil. So it's not like going to run this thing forever, but it will run it prolonged for, I'm thinking, up to 10 minutes, maybe more, of extra spin time. I've never seen it. It sounds like I'm supposed to know. Yeah, I'm using the kinetic energy to turn it back, basically, kinda. And I know that you can't do that forever, but you can do it for a shorter period of time. So yeah, there are a few shows that I watch, but I have not watched that one, sir. Bing Bang. I don't know who that is. So this here is a counter rotator. This is the stator, and you can see it's spinning. It's got 3 bifilar coils on it, 32 gauge and 20 gauge. The wedge formation. This rotor does not go with this, but we're going to use it anyway. So I'm going to give it a little spin here. Now see this battery pack right here, once I apply that to this, the shaking should stop a little bit. But the weight is a little off. That battery pack will fix the weight problem. But then it'll be a 36 volt system instead of a 24. And our wheel's still spinning at quite a rate, still moving quite fast. So cool, man. That thing gets going really fast. I'm having a sudden urge to really fix this. So I got to lift up the breadboard right here. Put the battery underneath that. And then put the breadboard back on top of the battery. And try to make it as flat as this coil. So it shouldn't be higher than the top of this. But it probably will be a little bit higher than the top of that. And we'll see if it'll still work being that high. But, I mean, doing it just on the whim right now. I don't know if I got it in there right. I don't know if I should have the leads, these ends in the middle, because the other ones are in the middle. I think I do need them in the middle. All right. Well, bam. Patchwork. Well, let's see if we can spin it a little bit. Oh yeah, that's a lot smoother. But that pole in the middle has only got one screw in it. So it's going to shake no matter what. Are you, what? Are you even listening? The pole is not shaked in there. Now that has officially stopped in my mind. All this motion doesn't really count. But I don't know what that means, cactus baboon. No, the amplitude, okay, the amplitude changed when it was turned off. It didn't stop wobbling when it was turned off. It just stopped wobbling at the same frequency when it was turned off. Okay. And there's two things going on here right now. There's this, which is a no, this is a pulse motor, which I'm messing around with, and this is a counter rotating pulse motor, which is now a 36 volt counter rotating pulse motor. $700. $800. Hell yeah, like I said, there's a magnet loose in this rotor, so everything's gonna shake. Hmm. think I got that 36 already. Nice. Let's see if it's gonna be no. See, I just unplugged the hot glue gun, and the residual heat was enough to melt the glue. Residual is enough to make it run. But, you know, eventually this is going to cool off. Eventually that's going to cool off, you know. At least the way I have it hooked up. That's the way I like to say it. If you hook it up a different way, you can make the same stuff doing way different things. Hopefully I hooked that battery up correctly. Nope. Nope. Gotta glue it in. All right. Let's hope the glue gun's still hot. Look, man, that's cutting it really, really close with the transistors. I think I'm going to move it up a little bit. Is it too much now? See, I think I need the stronger magnets. I'm gonna have to charge up the battery, I think, that I just put in there. Something's not right. That's what it is. Everything's kind of coming apart. Ready? Let me get this bearing in here. This is really heavy too. Like, yeah, I think it's good. I'm gonna work on this. I'm gonna make another rotor for this counter rotator that's gonna be able to fit bigger magnets in it. All right, let me just try and run this one more time, and then we'll call it for today. It's gonna be interesting to see if it'll run on 36. It should. Let me see. Yeah, no, maybe. I got an idea. I don't know if it's going to work with this setup. I can't have this breadboard that close to the magnets. So what do I do? What to do? I want to put it underneath, but all this wiring will have to be redone. I have to put it underneath. It's just too much magnetism. Yeah, I'll have to take that apart and put it back together again. I'm not going to do it right now because I will totally not put it together right. Let's see if we got some. We do. We got some excess wire for some of the connections. So those are the two grounds. Might not even be using a breadboard. All right. We got that off, and our objective now is to kind of put it underneath like this. All right, hell yeah. Taking control here. All right. I'll see you all later. Peace out. Have a wonderful day. Please subscribe, like, hit the notification bell, and share this content if you think it's cool. Peace.